Alright, welcome back guys. I'm back for another video, and in today's video we're going to do adding and subtracting polynomial fractions functions, and then we're going to add restrictions at the end when we have our final answer to figure out what the variables cannot equal to, right? So here we have our first example. You have 4 over 5x minus 2 over 3x. So before we start, let's practice and see how do we subtract a regular fraction. So if we have 7 over 8 minus 2 over 3. Let's see what we get. So we have to always multiply the denominator first whenever we're subtracting, right? So we start by multiplying 8 times 3, so we get 24, right? And then what do we do next? After we multiply the denominators to get a common denominator, we have to cross multiply. So we have 3 times 7, 8 times 2, and then we have the subtraction in the middle. So then we get 3 times 7, right? Minus 8 times 2. And then ultimately, what is our final answer? We get 7 times 3, which is 21, minus 8 times 2, which is 16, over 24. So then our final answer will then be 5 over 24. And then that will be our final answer of how to subtract regular fractions, right? So quick recap, we multiply the denominators to get a common denominator. Then we cross multiply and then fill out the adding or subtraction symbol that is over there. Okay, so now that we know how to subtract regular fractions, let's see how we can transfer this knowledge to a polynomial fraction. All right, so let's start. So we have 4 over 5x minus 2 over 3x. So what's the first thing that we do? We have to multiply the common denominator, right? So what's 5x times 3x? We multiply the two numbers first. So we have 5 times 3, so we get 15, right? Then we have an x over here and an x over here. And if you guys watched in the previous video about how to multiply and divide fractions, we know that it's x1 and x1. So if you get x1 times x1, it's the same thing as x1 plus 1, which is equal to x squared. So we know at the bottom is going to be 15x squared. Now, what are we going to do next? We're going to cross multiply. So we're going to do 3x times 4. And then 5x times 2. So what's 3x times 4 minus 5x times 2. And let's see, what is that equal to? Well, what's 3x times 4? So we're going to do the same thing when we multiply. So we have 3 times 4, which is equal to 12. So we're then, and then x times 1, which is just x. So we're going to get 12x, right? Minus, and then what's 5x times 2? So we have 5 times 2, which is 10. Then x times 1, which is just x, so we end up getting 10x. And then the bottom doesn't change, as it just stays at 15x squared. So then our final answer would then be 12x minus 10x, which then results in 2x over 15x squared. Now we have to simplify this even further, right? So when we divide, we get x over x squared. So when we get x over x squared, we get x1 over x2, which is the same thing as x1 minus 2, which is equal to x negative 1. And we know that if it's negative 1, all that means is that there's an x in the denominator. So ultimately, what this results in is just 2 over 15x, right? Because these x cancels out. So this cancels out with that, right? And the 2 cancels out, so it's just 2 over 15x, because we have x negative 1. So now we have to state our restrictions. So if this is our final answer, 2 over 15x, we have to see that there's a variable in the denominator, right? So label this as v in denom, right? In short form, so variable in denominator. So because of that, we know that the denominator can never equal 0. So is there a value that x can be that results in 15 times x to be 0? And that value is 0 itself, because 15 multiplied by 0 is equal to 0. So therefore, x cannot equal 0, right? Because our denominator can never equal 0. So this is our restriction. All right, so that's our restriction. So our final answer is 2 over 15x, and x can never equal to 0 as our variable restriction for this specific problem, right? So now let's go into another example of subtraction. So here we have our second example. We have 5 over x plus 1 minus 2 over x minus 1, right? So we're going to apply the same rules over here when we subtract these two polynomial fractions. So let's go ahead and just put brackets over here, right, to just know that this is one term, right? So now let's see what we can do. So what's the first thing that we do whenever we do this? We have to multiply the common denominator, right? So we have to multiply x plus 1 times x minus 1. So how do we do that? X plus 1 multiplied by x minus 1 is equal to, so we're going to do the first one, so we're going to do x times x and then x times 1. So we have x squared, right? X times x is x squared, and x times negative 1 is just negative x, right? Then we have over here, we have 1 by x and then 1 by negative 1. So 1 by x is just plus x, and then 1 times negative 1 is just minus 1. And then ultimately what this equals to is x squared minus x plus x minus 1 is that these two cancel out. Then we get x squared minus 1, right? So then our denominator is going to be equal to x squared minus 1. So now that we know that, now we have to do the cross multiplication. So we have to do x minus 1 times 5, then x plus 1 times 2. And that can be written as x minus 1 times 5 minus x plus 1 times 2. So now let's go ahead and do that really quick. Let's just erase this part. So now we have to multiply the top and then fill out the subtraction symbol, right? So the way we do that is we do x minus 1 times 5, right? So then we can do 5x. So we do x times 5. And then we can do negative 1 times 5, right? So we get 5x minus 5, right? Minus, and then for the second part, we have x plus 1 times 2. So we get x times 2 and then 1 times 2. So then we get x times 2 is equal to 2x. And then 1 times 2 is just equal to 2. Right? So this is our equation. And what is that equal to? 5x minus 2x results in 3x. And then negative 5 minus plus 2 is equal to positive 3. Right? And then we have negative 5 minus plus 2 is just equal to negative 5 minus 2, which then results in 3x minus 7, right? So then that would be what our top is equal to. So then ultimately we get 3x minus 7 over x squared minus 1. Now, in this scenario, this is what the answer is equal to, but then now how do we find restrictions? Because one thing we have to remember is that this is one specific term, right? So 3x minus 7 is one term, and x squared minus 1 is one term. So what can we do to find the restriction? Now, one thing that we can do is, what is this called? We have x squared minus 1, right? And whenever there's an x squared, we know that that is equal to a quadratic, right? So we have a quadratic, right? And whenever we have a quadratic, we know that if it's concave up or concave down, there are always 2 0 points on the y-axis, right? So quadratics have 2 zeros, right? So we know that there are two values for x, right? There are two values for x that result in this the denominator being 0. So how can we find those two values for x? Well, we have a special tool that we can use, the quadratic formula, right? Quadratic formula. So if we have x squared minus 1, we know that x squared is our a, our b is equal to 0 because there's no term here, and then our c is equal to 1, right? So knowing that, we know our quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a, right? So if we plug these values into this equation, right? So if we put in our calculator after, we get that x is equal to what? So we plug that in, right? And we use our calculators. We get that x1 is equal to 1, right? And then we get that x2 is equal to negative 1. So that means that if x1 and x2 are negative 1, right? So let's write down if x is equal to 1 or x is equal to negative 1, then the denominator is equal to 0, right? And we know that the denominator can never be 0. So for that reason, we know that x cannot equal to 1 or negative 1. And that is our restriction for this problem. So x cannot equal 1 or negative 1, because if x is equal to 1 or negative 1 for this right here, we know that the denominator is equal to 0, right? So our final answer is going to be 3x minus 7 divided by x squared minus 1, and therefore that results in our final answer. And we know that x squared, or the x, for example, in this denominator cannot equal 1 or negative 1, because in that case, then the denominator will be equal to 0, which is our restriction, right? So that's the answer for problem number 2. So let's go ahead and start problem number 3. Alright guys, so now we're on example 3, and we're going to do an addition question for polynomial fractions, and this will be a great test question for any unit test or chapter test. So the first thing that we're going to do is, as you can see here right off the bat, we can see that the denominators, right? The denominators are both quadratic equations, right? Because they're x squared. So what we're going to do is we're going to try and find out what x is equal to. So we're going to use our big old formula again. Negative b plus minus b squared minus 4ac divided by 2a, right? So then this is going to be our a, b, and c, and our a, b, and c for both ones, right? So we have 1, 3, and negative 4. Then we have 1, 1, and negative 12 in our quadratic equations. So ultimately, after we put that in our calculators, let's go ahead and do that real quick. And then this is what our new formula is going to look like if we put that in quadratic form, right? So if we put that in our calculators and we use the quadratic equation, what we get is we get 1 over x minus 1, and then we get 1 over x plus 4, right? And this one plus 1 over, and if we use a quadratic formula again to do the next part, we get 1 over x minus 3 and 1 over x plus 4, right? Now what we're going to do is we're now going to multiply the denominators, right? So our rules for addition and subtraction of polynomial fractions remains the same. So what we're going to do now is just multiply both denominators, right? Now we don't have to go into the extent of multiplying everything, but we can just find the common terms. So we know that x plus 4 is common between the both of them, and the only different ones are x minus 3 and x minus 1. So now let's see what happens when we have to do our numerator, right? So for our numerator, we do the same thing, right? So when we multiply the denominator for our numerator, we do the same thing, and we have to multiply the top and the bottom through cross multiplications. All right, now because we have terms that are the same, we know that x plus 4 is the same here and x plus 4 is the same here. Now when we cross multiply, we don't include the x plus 4 because the x plus 4 is similar on both denominators. Now ultimately what our denominator is going to look like in totality, right? It's going to look like this. So we're going to have x minus 1, x plus 4, and then we're going to have x minus 3. Now the reason why we don't include x plus 4 twice is because x plus 4 is already on both sides, right? So we don't have to do that. So now when we cross multiply, all we have to do is cross multiply the ones that's missing on either side, right? So on the left side, it's going to be resulted in x minus 3, right? So we're going to bring over the x minus 3 from over here to over here, right? And we're going to multiply that by 1. I'm going to add that. And then x minus 1 is the one that's missing. So we're going to bring that one to the top. And it's going to be x minus 1 times 1, right? Now we don't have to include the x plus 4 in the cross multiplication because the x plus 4 is already included in both sides, right? So we only include the one that's not on both sides. So on the top, we're going to get x minus 3 times 1 plus x minus 1 plus 1, which is ultimately x minus 3 plus x minus 1, which is ultimately x plus x, which is equal to 2x, and negative 3 minus 1 is equal to minus 4. So on the top, we're going to get 2x minus 4. So our final answer is going to be 2x minus 4 all over x minus 1, x plus 4, and then x minus 3. And that's going to be our final answer. But wait, we're not exactly done yet. We have to see if we can find the restrictions, right? So let's see if we can find the restrictions for this one. So we have x minus 1, x plus 4, and x minus 3 in the denominator. And we know that none of these brackets, this bracket, or this bracket, cannot equal 0, because anything times 0 is going to result in the denominator to be 0. And we know that we can never have that. So we have to set restrictions. So what are our restrictions? What value of x in this bracket of x minus 1 is going to result in the bracket being 0? So a quick way to solve this is if we do x minus 1 is equal to 0 and we bring the 1 over, we know that x is equal to 1. So if x is equal to 1, we know that this bracket is going to be 0, resulting in this denominator being 0, right? So we can't have that. So we know already that the restriction is x cannot equal to 1, right? So if we do the same thing over for these brackets too, we know that x cannot be equal to -4 and x cannot be equal to 3, right? So 1, -4, and 3 are our restrictions for this specific problem, right? Because we know that the denominator can never equal 0, okay? So therefore, that's the end of the video, guys. Hope you guys enjoyed and understood how to add and subtract fractions. If you guys have any questions or concerns, please comment down below. If you guys want me to cover any specific questions or topics, please comment down below as well, or send me an email at sharranacademy@gmail.com, guys. Please remember to like, comment, share, and subscribe. And thanks for watching.